In this video, we will cover the relationship between magnetism and electromagnetism. Magnetism is the physical phenomenon that's produced by the motion of electric charges resulting in either the attraction or the repulsion between two objects. Electromagnetism is going to be that interaction due to electrical currents or fields associated with the magnet. So that a magnet is any substance that can attract iron or other magnetic material. Magnetism itself is a force of attraction or repulsion. It's due to the arrangement of electrons. Inside of the magnet, there are domains. When the domains are randomly arranged, the forces are canceled out and there's no net magnetic effect. When the domains have their magnetic effect, this is because there's an alignment. The forces would be additive and it would create a strong magnetic effect. You can see both forms in the diagram below. Since magnetism and electricity are closely related, we can use this to help make magnets. Temporary magnets are going to be magnets made when the material becomes magnetized while in contact with a strong magnet. For example, if we look at the picture on the bottom right, we have the paper clip is able to pick up more paper clips, or in this case a nut, because it's stuck to a stronger magnet. A permanent magnet is material that maintains their magnetism when the magnet is removed from it. Natural magnets would be like magnetite, and they occur in nature. Temporary magnets are magnetic for a short period of time, for example, soft iron. Permanent magnets stay magnetic, for example, iron or nickel. The simplest kind of magnet is just a straight iron bar magnet, and the process where some materials made into a magnet is called magnetic induction. The poles of the magnet are the ends. Now the poles will either have a positive charge or a negative charge. If we take two magnets and we put them pole to pole or end to end, if the two poles both have the same charge, they will repel. If they have opposite charges, they will attract. Now you can take an unmagnetized piece of iron and you can magnetize it by stroking it with a magnet. This is caused by induction, and if the piece of iron is placed near a stronger magnet, it will become magnetic. We've mentioned soft versus hard magnets before. The soft magnets are temporary magnets, such as iron. The hard magnets are cobalt and nickel. These would be permanent magnets. When we talk about magnets, we also talk about magnetic fields. Magnetic fields is a vector quantity. Now, the magnetic field lines can show up by using a compass, and we can use a compass and a pencil and map out where the field lines are. We can visually see it if we were to use a magnet and iron fillings, and we could visually see the magnetic lines form. And so they look very similar to what we have right here, where we have our north and our south. And so we can see how our field lines would eventually, if we were to bring this out, would come around and come back around like this. And in this area, you would have field lines that would come along those lines. But they go from north to south and then north to south there. So we could use a compass to do this and sketch out the lines, or again we could use iron fillings and show this visually. Here we have the iron fillings to show us, and you can see the south versus the north, and you can see the direction of the field as it moves from north to south. Now here you'll notice we have a north and a south, so we're going to have attraction, and you can see how those magnetic field lines are being attracted, and you can see how that varies from if we were to have one magnet by itself. Now look how the previous slide compares to, here we have north and north, and you can see how right across here they're repelling, and how instead of coming across, these are being forced back in this direction, these are being forced back in that direction, but you can see that repelling where opposite charges attract and like charges repel.